Right, but let's start with our algebra, guys. Let's get into it. So algebra, we did a lot of last term. So if you were with me last term, you will know that we did algebra until it came out our ears. I think I even got over algebra. Like, there was a lot of algebra, but algebra is so important. If you are not feeling comfortable with algebra, it is something that you really need to spend time revising and spend time trying to gain confidence in. Because unfortunately, whether you like it or not, if you're going to do maths until matric, algebra is a part of your life, and it is a big part of your life. And even just the basic concepts that we teach in algebra, if you don't want to do maths and you want to do maths lit, it does help in sort of problem solving questions. So it's very important that we can do algebra. Oh, excuse me. Okay, so just some basics. We're going to do basics today and Wednesday. And then, like I said, we're going to use what we've learned to then go and solve equations. So in this first example, I've given you an expression. Now, guys, remember, an expression is a set or a mathematical sentence that contains a whole bunch of terms. And each of those terms has a value or a meaning in this mathematical sentence. Oh, my nose. So I've given you 6x squared y minus 7xy cubed plus 8xy minus 9. That is the expression that I've given you. So the very first question that I'm asking you, and this is now testing in a bit of terminology because we need to know each of these things in order for us to go a step up now in algebra. The first question I'm asking you is, how many terms are there in this expression? So now, if anyone would like to raise their hand to tell me how I identify terms or how many terms are in this expression, you are welcome to. Otherwise, on the chat, how many terms does this expression have? Tandawake, tell me.
Ma'am, there are 4 terms.
Perfect. And how did you know that? Like, how did you identify your terms?
Well, ma'am, because it was splitted, ma'am, also by a minus and a plus. That's
Good.
how.
Good. Okay. So, guys, exactly what Tandawake said. There's 4 terms, and we know there are 4 terms because terms are separated by plus and minus signs. So remember, we don't care about plus or minus signs that are in brackets or in fractions. I don't have either here, so that doesn't matter. I've got a minus, a plus, and a minus. Those are separating my terms for me. So here's my first term, my second term, my third term, my fourth term. So exactly, I have got 4 terms in this expression. You don't have to write the word terms. 4 is good enough, but there are 4. Right. No, never mind. Okay, 4 terms in the expression. The next question is asking us, what is a constant, or what is the constant term of the expression? So again, if anyone wants to raise their hand, can you tell me what a constant term is and what the constant term is in this expression? Or you can put it on the chat, up to you. Sinyane?
Hello, ma'am.
Hi.
The constant term is 9.
Okay, good. And how did you know that?
Because it doesn't have a variable.
Excellent. Okay, so guys, remember, a constant term is a term that has no variable. So when I'm asking you what is the constant term, you now need to go and look at the terms that you've identified and find the one with no variable. So the one with no variable is here right at the end. And just be careful, the sign in front of the term is that term sign. So here, our constant term is -9. It is a negative value. We need to remember that. But exactly, no variable, that's what we look out for. Alrighty. The third question, or question C, however you want to go about this, is now asking us for the coefficient of the xy cubed. So again, have a think, either on the chat or you can raise your hand. What is a coefficient? And what is the coefficient of xy cubed? You can put it in the chat. If you're feeling up to it, you can raise your hand. Nice, Butle. Tell me, Butle.
The coefficient of xy is is 9 because the coefficient is the number in front of a variable.
Okay, good. So guys, let's just start with the definition part. A coefficient, I don't know what's happening here. A coefficient is the number in front of your variable or set of variables. So in this case, I want the number that is sitting in front of the xy cubed. Your coefficient is being multiplied with that variable. All right, so now we go back up to our expression. I look for the xy cubed. There it is. The number in front of it, oopsie, is -7. So here my coefficient of xy cubed is -7. Okay, that is the number in front of the set of variables or the variable group. Sorry, I'm trying to get in my desk here. Xy cubed. Now, very importantly, guys, I specifically in this question said xy cubed. If you have a look at question D, it's basically the same question, but I'm now asking for the coefficient of just the term xy. So now we have to go up to our expression and we need to look for the term that is only xy. That is this positive 8xy. So the number in front of it is positive 8. So be very, very careful when you are asked for a coefficient that you are looking at the correct term to find that coefficient. So that's why I put those both there. They're asking essentially the same thing, but they're asking for the coefficient of different terms. One is of xy cubed, one is of just xy. And because they are different terms, they likely have different exponents. So please read your questions carefully and make sure you are looking at the correct term. Okay, so that's really important. Excuse me. Question E is asking then for the degree of this expression. Honestly, I hate questions that involve degree. Not because it's useless, it's actually quite a helpful concept, but we don't often actually talk about degree. Okay, so just as a quick recap, mostly because we didn't spend a lot of time on this, degree is the highest exponent or the biggest exponent of your variable. So this question would need to be a little bit more precise, and I will do that now. We would need to say, what is the degree of this expression? And then I'd have to tell you which variable to look at, x or y. So if I said, what is the degree of this expression? Let's see if it'll do this. In terms of x, this is asking me to look for the highest exponent of x. So again, we have to go back to our expression. Highest exponent of x. So we go back up to our expression. I don't know why I keep drawing arrows. You can see the expression. And all you want to do whenever you are asked for a degree is look at your x variables. So let's just take these arrows and highlighting and all the rest of it off. Look at your x's and tell your teacher or tell me which one has the biggest exponent. The one with the biggest exponent is 2. So the degree of this expression in terms of x is 2. That's the highest exponent. If I had asked for the highest exponent or the degree in terms of y, so let's just go degree in terms of y, we do the same thing, but now we look at our y variables and we answer which one has the highest exponent. The highest exponent is y cubed. So the degree in terms of y would be 3. Now, like I said, we don't actually often, like we'll ask you questions like this, especially in grade 8 and grade 9. But honestly, from then, we don't really deal with this term. The reason this is useful, though, is when we get to equations. When you start dealing with more and more complex equations, you start to see a bit of a pattern forming. So when you have an equation that has, let's say, for example, an x squared in it, and you're solving an equation and there's an x squared, the degree of your expression actually gives you an idea of how many answers you should get for your equation. So if your equation has x squared in it, you should get 2 answers. If your equation has x cubed in it, you should get 3 answers. If your equation has x to the power 4 in it, you should get 4 answers. And so we keep going. So the degree helps us figure out how many solutions we should be working with for a specific equation. Like I said, we don't do a lot of degree questions, but the idea and understanding what degree is super important, especially as you go on in algebra and start doing more and more complex algebra and equations. Okay, since Walo, you can't put the degree of X and Y unless I specifically said, no, you can't do of two variables. So the reason for that is because often those variables will have different exponents. And so you would have to pick one. And so the question would have to say which variable you're working with. So in this case, I had to specifically say in terms of X or in terms of Y, because even if it was X and Y, what's the daisies? You can see that you've got terms with X, Y, X, Y, X, Y, but they all have different exponents. So then it becomes a trick of now which one do you choose? So it has to be one specific variable. Okay. Samtanda, do we have to put the negative sign in question B and C? Yes. Remember I said the negative sign or the sign in front of the number is that number's sign. So the negative in front of the 9, let's just go back up here. This negative in front of the 9 belongs to that 9. It is -9. So you would need to put that negative sign with that value. Same with the -7. Okay, guys, I'm just going to stop here for a second. If anyone has any other questions, please, you are welcome to put them on the chat, or you can raise your hand at this point. We've got one more question in this example, but this is a lot of the terminology. So I just want to make sure we're all okay with that before we do the last question and then move on. Okay. Right, so the last question says, if X is equal to -1 and Y is equal to 2, determine the value of the expression. So just because I'm a bit lazy, I'm just going to copy this expression down here for us. Whenever we give you values, so here I have given you specific values that I want you to use X and Y. What you need to do is you need to use substitution. Substitute. Okay. In order to substitute, you need to know where your X's and Y's are. So if we've got X is equal to -1, anytime you see an X, you are going to replace that with a -1. I've also told you that Y is equal to 2. So anytime you see a Y, you need to replace that with a +2. Now, guys, very important. When you substitute, you need to use brackets. Now, the reason for this is, if we just take the first term, 6x squared y, remember, this term is saying to us 6 times x squared times y. So if we use those brackets, it reminds us that we are multiplying. Okay, so in our substitution, everything that is not an x or a y is going to stay the same. So the 6 stays as it is. But now in place of that x, we need to substitute -1. And importantly, that -1 or that x was being squared. So this is -1 squared. Right, then we've got a y. Y was 2, so that would be times 2. And that is me substituting x and y for the first term. Move on to the second term. The -7 stays as it is. X is -1. I substituted in. Y is 2, but that y was being cubed, so I also need to cube it. Third term, plus 8x, which was -1, y, which is 2. And remember, the last term is a constant. It's just -9. There's no variables, so it stays exactly as it is. And now that you've got only numbers, you need to start applying your BODMAS. Just quickly while I'm here, Taboko, I'm not too sure what you mean. Do we add the exponent? I don't know if maybe I've already answered that in explaining it, but if not, when I'm done and I say raise your hand, please do raise it, or you can try rephrase your question for me. Okay, so guys, now we have to go and simplify this. Now we have to apply BODMAS. whenever we're trying to simplify, a BODMAS has to apply. And also just remember that you've got your 4 terms here. So if you simplify each term, you can then just add or subtract them. So let's start with term 1. Okay, I've got 6 times -1 squared times 2. So if we just go on the side here, 6 times -1 squared times 2. -1 squared is -1 times -1. So a negative times a negative. We know that's a positive. So actually what we have here is 6 times 1 times 2. And we know that 6 times 1 times 2 gives us 12. So my first term simplifies to 12. And I'm going to keep doing this with each of my terms. If I look at my second term then, just go here, well, -7, if you want to put it in brackets, that's fine, times -1 times 2 cubed. Now remember, 2 cubed means 2 times 2 times 2. 2 times 2 times 2 we know is 8. So I've got -7 times -1 times 8. Negative times a negative is a positive. 7 times 8 is 56. I'm not very good with my 7 times tables, 8 times tables. So now I've got minus 56. My third term, I'm not going to keep doing that. Hopefully we get the idea. I've got positive 8 times -1 times 2. Positive times a negative is a negative. 8 times 1 is 8, times 2 is 16. And then we've got that -9. So all we've done here, guys, is we simplified each of our terms. And now I will just put this on a calculator. There's no need to try and do this in your head. If you are comfortable and want to do this in your head, by all means, go for it. I'm not going to do it in my head because it's been a long day and I'm not sure if I back myself. But if you go and do this in your head, or if you go and do this on a calculator, you get a final simplified answer of -69. So you have gone and simplified the expression or found the value of the expression when I've told you what X and Y need to be equal to. Okay, so in this question, important things to take note of. You need to know your terminologies. You need to know what a constant is, what terms are, what a coefficient is, what the degree is, etc., etc. And you need to be able to substitute. Okay, substitute means replace. If you are substituted in a sports team or if you are a sub, you are going to replace someone. So you are replacing variables for values. Right, so I've just made this a touch smaller so you can take a screenshot of everything. While everyone's screenshotting, if you've got questions, please raise your hand. Otherwise, we are going to move on. So I'm just letting you take a screenshot if you need. Atlacha?
Ma'am.
Yeah.
Ma'am, this is not related to the work, ma'am. I did the quiz last week, ma'am, but it said my quiz was not attempted, ma'am.
Okay. Pop Yolanda a message, please, and hopefully we can pass that on and see what the issue is.
Yes. So remember grade 8, everybody who's doing quizzes, do not change any names there when you are busy doing your quiz. I know you're not the only one because I had again in grade, I'm not sure which grade it was, that they also couldn't see their quizzes. But don't worry, today is not a quiz day. I'm just gonna submit your name, okay, to our team, and let's see what they can do to help, okay? But normally do not change your name, don't do anything. You click on that the way that it is, you just answer the questions. You do not change what they have put there for you as a name.
Okay, but Atlahang will pass that on. Hopefully we can get it sorted before Wednesday.
Yes, ma'am.
Alrighty, guys. Excuse me. I'm hoping you've all got your screenshots. Let's simplify a few and then we'll take a bit of a brain break. Okay. So in algebra, like one of the main things that we do with algebra or algebraic expressions rather is we need to be able to simplify. Okay, now there's also things that we need to remember when we simplify. And as we go through these, we'll chat about them. But very importantly is, again, BODMAS, or the order of work. You need to do that correctly. And secondly, like terms. Okay, so first thing we always check for in an expression when we're wanting to simplify is we check to see if we've got any multiplication, division, or exponents. Because if we've got those things, remember, we know according to BODMAS, we have to do them first. Or brackets, but let's put brackets in there. Okay, so I always double check that. In this case, I don't have any of those things. So what I now need to move on to is my addition and subtraction. That is where like terms becomes important. Okay, now I have said like terms so many times this year. If we don't know what a like term is by now, I'm worried. But like terms, or I don't know which time it is, are terms that have the same variable and exponent. So they've got the same variable or groups of variables. So xy is a like term to xy. And the same exponent or exponents. All right. So that's what we look out for like terms. Now, I've said this to you before. If you've been with me since the start, grab a highlighter, grab a colored pen, do a squiggle, whatever you want to identify your like terms. So when I do like terms, I often have a highlighter and my page gets a bit like unicorn vomity, but it's fine. I can find my like terms. So if I just start with my very first term, which is 2x, I want to identify all terms that have an x and an x only in it. So my second term is 4y, not the same, or not a like term. Then I've got negative 3y, not a like term. 9, not a like term, doesn't even have a variable. But the last term has a single x in it. So the 2x and the negative 5x, they are like terms. Once I've got to the end of my expression, I start again. So now I move to my second term. My second term is a term with just a y in it. So now I find all terms with just y's in it. That would be the negative 3y. And then what we see is at the end here, I have this negative 9 just chilling. It's a constant, doesn't have a variable. There's no other constants, so can't do anything with it. Once I know what my like terms are, I add and subtract them. So guys, very importantly, you can only add or subtract like terms. So I'm going to put a little note here. We can, maybe I'm not going to put a little note here. Let's see. There we go. We can only add or subtract like terms. So basically what that means is I can only add or subtract blue and blue, pink and pink, green and green, whatever. If they're not highlighted in the same color, can't add or subtract them. Okay, so some people like to, you don't have to, but some people like to group the like terms. So what I mean by that is 2x minus 5x, they've put the x terms together. Then plus 4y minus 3y, they've put the y terms together. And then plus 9. I haven't changed anything. All of these terms are still exactly the same. All I've done though is I have grouped my like terms together. Now you can do this if you want to. I don't know what's happening. Okay. You can do this if you want to. You don't have to. Some people find it a little bit easier to do addition and subtraction of like terms when their terms are together. That's fine. Makes absolutely no difference. It's what you're comfortable with. And if this is what you're comfortable with, do it. Sorry, everyone. Right. Now I add and subtract. 2x minus 5x. If you struggle, number one, get your calculator and say 2 minus 5. If you're not allowed a calculator, draw a number line. 2x minus 5x gives me negative 3x. 4y minus 3y gives me 1y. If you want to write the 1 there, you can. You don't have to. So if you just write y, that's fine. Now that +9, it's got no like term, so it's not going to change. It's going to stay +9 because I'm not adding or subtracting anything to it. You are now done. You are now done because you can only add or subtract like terms. There are no more like terms there. You can't do anything else. You're done. Okay. So when we're simplifying expressions, we always double check our order of work, see if there's any BODMAS that we need to sort out. And then we have to identify our like terms. Guys, I can't stress this enough. If you are not identifying your like terms, you are not doing correct algebraic maths. You're just making up nonsense. And we don't want to make up nonsense. Okay, so based on what I've just said, based on what we've done, I would like you to please try question B, and then we'll take a little break. I want answers in the chat. If you have questions, put them in the chat, but try question B. Remember, like terms are terms that have the same variable or groups of variables. So importantly, x by itself and say x, y are not like terms. One has just an x, one has x and y. You need to group all the terms that have just x and all of the terms that have just y and all of the terms that have x and y. They will be separate groups. I've given it away here, but try question B, put your answers in the chat. And remember, guys, use your highlighters, use your colored pens. If you want to underline with a solid line and a squiggly line to separate your terms, that's fine. Do what you need to do to make it easier at the end of the day. Good, guys, keep those answers coming. I'm going to give you another minute or so, and then we'll have a look. Good, grade 8s. Okay, so first thing we do, identify our like terms. So that's what I've done here with my highlighting. I will make it small again for you to screenshot just now, don't stress. If you want to, you're welcome to write your like terms group together. Personally, I don't do this, but having said that, often what happens is we make mistakes when we add or subtract our like terms, especially when there's lots of terms. We maybe forget one, we maybe miss a sign. So sometimes actually writing your like terms all grouped together is quite helpful, making sure that you've got everything there that you need to work with. Okay, now we just add and subtract. Would help if I wrote, did I not just say we miss things? There we go. So -6xy minus 2xy. Remember, they are like terms because they have an x and a y. If we subtract those two, we get a negative 8xy. Moving on to our next group, 7y plus 8y, positive 15y. And then that little 3x is all by itself, doesn't have like terms that we could add or subtract to it. It is what it is. Now, importantly, guys, it has to be written as one expression. It was originally an expression, so it needs to remain as an expression. You've just simplified it. This expression could be in any order. So if, for example, you had written 15y minus 8xy plus 3x, that's exactly the same thing. You've got a positive 15y, you've got a negative 8xy, you've got a positive 3x. If the order is different, it really isn't the end of the world as long as your terms are correct. All right, but if we just go in terms of the order we were given, our simplified expression, negative 8xy plus 15y plus 3x. I can't simplify further because there are no more like terms. I'm done with my like terms. It is simplified. Alrighty, so screenshot. While you're screenshotting, if you have questions, please ask. Otherwise, we're going to do a little brain break because, like I said, we've done so much algebra and it's not a bad thing. Don't get me wrong, but we have done this ad nauseum and there are lots of videos if you want to see.
And you guys are doing amazing well, guys. And I love those colorful colors. Didn't you miss colorful colors, people? I miss them. Look how colorful the board is. It's so nice. We're seeing it perfectly.
Okay, guys, and don't forget, Yolanda always tells you this. Make sure that once I've done an answer, you are checking your answer. You need to be marking your work. So I asked you to try this one. Your answer should now be marked and fixed and adjusted so that it now is correct. If you're not understanding why we've got what we've gotten, you need to be raising your hand now. Like I said, raise your hand if you have questions, or you need to be asking on the group, or you need to be sending Yolanda or myself a message so that we can help you. Oh, Matlahang, sorry.
Ma'am,
Yeah,
for E, ma'am, what is the answer, ma'am?
for E.
Yes, ma'am, the degree of this expression.
Oh, so the degree of this expression in terms of x, it's 2.
Oh, yes, thank you, ma'am.
Sure. I was confused for a second there. Okay, guys, and then just a reminder, once you have finished talking or asked your question, just remember to mute and lower your hand, like Atlahan did there. Righty, I'm assuming no more questions, so let's take a little brain break. So those of you that are new, brain break is essentially what it says. It's a break for our brains. It's still sort of mathy, but we just take a moment and we try and solve a puzzle. Sometimes it's guess the phrase, whatever it is. And guys, how many times have Yolanda and I told you this is going to help you with equations? We're about to start equations next week. So these brain breaks hopefully mean that we're going to do really well with equations. So brain break. Remember what you want to do here is you want to work out the value of each of these pictures to get me the final answer. Please take note of where there are 2 images. So here, for example, I think that's a train. There's 2 trains, but in the last one, there's only 1 train. Take note. Please also take note of your operations. Remember, BODMAS must apply. If you're not doing BODMAS, you've made up maths. So give it a try. I will make it bigger in a second for everyone, but give it a try and tell me what that final answer is. Remember, all we want on the chat is the final answer, and the first person to get it is going to explain to us how they got that answer. Okay, I've made it a bit bigger. Hopefully you can see where there's doubles and where there's singles. Yolanda has the answer. I have the answer. We're looking out.
Yes, and I have the answer, guys. I cheated. Just Sam gave me the answer.
Teacher Sam was also prepared today and did it beforehand rather than sitting here like, oh my gosh, I got to do it.
We have an
Atlahan,
answer, guys.
Atlahan, can you not see the screen at all? Or what is the problem? Do I need to reshare my screen? I think I'm just going to reshare it in case. So guys, don't panic. I'm just going to stop sharing my screen for 2 seconds. I'm going to reshare it. Hopefully, if you were struggling to see, you can now see what's going on.
If not, I just shared also some information there for you that you can follow.
Thank you.
It's your network, Atlahang. If you are stuck, you need to sort of go out of Zoom and come back again, apparently.
Yeah, we're back to fun load shedding. That just messes us around.
Yeah, I'm having now like load shedding now. It's 6. Okay, guys, let's go. Are we trying it? Tando, I see you. You are so focusing. Courtney is looking at me. Courtney is like, what's going on? Kenny Mugal, let's just give it a try. Give it a try. I'll help you out.
Think of it like an equation. You're solving for X. You're solving for the train. I don't know if that helps at all, but when we do equations, I promise you, hopefully these will, these will hopefully be easier.
Yeah, I think so also. I see Siam Tanda is also focusing. Akani Mugai, where are we going? We're supposed to be doing an equation. And Akani is like, ma'am, I'm just moving. I'm going somewhere.
Oh, no,
Just let me get to my destination. You, my people. I love you guys. You're amazing. And there's someone here that I know I didn't forget your name. Ayo. Ayo got tired of us telling us, please change my name, ma'am. I saw that I didn't change it. I didn't change Ayo's name. Ayo is the liked group.
I even have it
sorry.
written down somewhere, and then I also forgot. I maybe need to keep a little.
But we didn't forget your name. You see, now I know your name. I know your Ayo for sure. So now you don't have to worry about us changing your name. Now we know your name. For sure that we know it. We're not going to miss it. Anyone gotten the answer yet? Time is going. Anyone?
Oh, guys, we're slow.
Anyone
Hey?
close?
Holidays were really good.
Yeah, our brain are still on holidays. That's what happens. Nice choice, Boniso, but it's not 190. Let's go. So anyone who's getting 190, it's not 190. Let's go, guys. But I love the trying, the calculations, just recheck your calculations while someone else is still checking their own and trying to find an answer. I'm gonna give hint because I see we're running out of time. So remember that the buses there, you see there are 2 of them, but you don't have to worry. You can make them as one just to find out what 2 buses mean. So if we can say x plus x plus x, we have 3x. Then let's solve for x. Then when you find that, you need to split that answer into 2 so you can know what does 1 bus mean, right? And it's part of what you get there on your answer, what you need on your answer. So let's.
Loazi.
Oh, Loazi. Okay, sorry. Am I saying a girl? It's a guy. So Loazi, raise your hand. Yeah, I'm better at that, guys. Loazi, raise your hand and you can explain to the rest of the class. Explain to the rest of us. I'm unmuting you, girl. Let me refrain of using girl. Hi,
Hello, ma'am.
Hi,
ma'am.
I knew that you're a boy. Okay, I'm gonna give the platform to you.
I say you go girl to men, women, dogs, cats, whatever. Okay, sorry, Loazi. I'm ready.
Ma'am, the first one I said 14 plus 14 plus 14.
Good.
Then the second one I said 10 plus 14 times 10.
Sorry,
the third one,
yes.
The third one I said 5 times 5 plus 6.
Good.
And the last one I just 12 plus 7 times 10 equals 82.
Perfect. Well done. Okay, so guys, remember BODMAS. If you're not doing BODMAS, you're doing nonsense, right? So just quickly for the second step, because you know the double bus is 14, you now have to ask yourself 14 times what, and then adding that same value gives you 150. So according to BODMAS, this gives us 140, and 10 plus 140 gives us that 150. Then quickly, Lwazi said in the third step that this boat now is 5. That's true because 2 boats was 10. So 1 boat is only worth 5. So it's important to look at your pictures, do BODMAS, and you will get your answer. Lwazi, well done. Thank you.
Thank you, ma'am.
Sorry, I needed to have a little cough there. All right, so guys, like I said, this is solving an equation. You're going to be able to do this algebraically, hopefully from next week. But it's still like training your brain to think mathematically. All right, we don't have a lot of time, but we're going to do one more example, just practicing order of work. No, we're not, because order of work's coming next week. Fine. Let us have a look at, in the last 5 minutes, I want you guys to try D and E for me. Okay, so I'm going to give you 4 minutes. We need 1 minute to go through it. 4 minutes to do D and E. Put your answers in the chat. Remember to label them D and E. I'm going to reshare my screen now. Try D and E for me. I'm going to give you 4 minutes, and then I'm going to explain in the last minute, and then we sorted. I know the screen is gone. I just need to reshare.
Yeah, no, I think at the hang is the same problem. It could be network on your side, love. You can try the message there if that didn't work. If you still can't see anything, try to follow that example that I've posted, and hopefully you survive.
Okay, guys, I'm going to give you one hint for E. The order of the variables might be switched. So double check that if you've got A, B, C, all A's are squared, for example, all B's are cubed, for example, and all C's are to the power of 4. So just make sure they match up. The order can be switched. Remember, X, Y is the same as YX. So order doesn't matter. Make sure that it's the same group of variables with the same exponents. That's my hint for E. Remember, you're identifying your like terms and you're simplifying that expression.
The dedication from all of you guys, amazing. I see Tando is like, I'm in a dark, I don't care, I will write these things, ma'am. I can see it. Hey, Tando Laki, well done, man. We're so proud of you, we see it. And Boniso also just went on the darkness. Hey, Boniso, finish this question and that's it.
You guys are doing well.
Y'all are amazing. Guys, I used to study with candles. That's how old I am. So to let you know, because electricity wasn't that much yet, you know. So y'all are doing well. Unfortunate.
Oh.
So just you have phones to touch yourself and to write down things.
True.
Okay, most of you have already done with D, I see.
Okay, guys, because I don't want to run out of time, I'm going to go through. D was looking good so far. So remember, like terms, we've got an x cubed, a 2x cubed, and a minus 7x cubed. That's one group of like terms. Then I've got this negative 5x squared, different exponents, so different groups of terms. And then finally, we've got that constant negative 10. So if we group our like terms, if that's helpful to us, x cubed plus 2x cubed minus 7x cubed minus 5x squared minus 10. Add and subtract your like terms. X cubed plus 2x cubed is 3x cubed. 3x cubed minus 7x cubed, negative 4x cubed. Now the minus 5x squared doesn't have any like terms, so it's just minus 5x squared. Same with the 10. That was weird, but we get it. Okay, it looked like you guys were getting that. So just remember, like terms, add and subtract them. If there's no like terms to a term, it just stays exactly as it is. Doesn't change. All right. For D, though, there were a lot of A, B's, and C's going on. So what might be helpful before you even start thinking about like terms is putting them in alphabetical order. So the first one is fine. It's A squared, B squared, C. Second term is also fine, 6ABC. Third term is also okay, A squared, B, C. It's in ABC. But now when we get to the fourth term, that's not in ABC. So let's reorder it to A squared, B squared, C, and the last term I'm fine with. Now, the reason that's helpful to me is because now I can very clearly see that A squared, B squared, C is a like term to 2A squared, B squared, C. They've got the same variables with the same exponents. Separately, I have a group of just A, B, C, all of the exponents of 1. And then I've got my final third group where only the A is squared. So I've got 3 groups of terms here. Again, if you want to rewrite them, that's fine. I'm not going to, just to save some time. 2A squared B squared C plus A squared B squared C is 3A squared B squared C. 6ABC minus 4ABC positive 2ABC. And that blue term, the A squared BC, doesn't have any like terms, so it just stays exactly as it is. So sometimes, guys, what you might want to do is reorder your variables so that they're alphabetical to make it easier to find your like terms. That's absolutely fine. Remember, x, y is the same thing as y, x. So if you want to reorder your variables to make it easier for yourself, do that. Okay, so I'm going to leave that there for a second or two.